So hi everyone, my name is Gabriele Bartolini, and today I'm here with Leonardo to talk about Kubernetes. Okay, how many of you use Kubernetes in production? Raise your hands. 3, 4, 5 brave people. Okay, I'm saying brave because this is normally a database audience, okay? But I'm pretty sure that things will change in the future, okay? So at least that's my, that's what I think, okay? And you'll see this throughout the talk, the presentation today. We believe strongly that this will be the future for Postgres, okay? At least one future. So, Leonardo, do you want to introduce yourself first?
Can you hear me? Yes. So I'm Leonardo. I'm working currently and I'm a Postgres user since a bit of time. I'm also proud to be a Kubernetes CSI organization member from last year. And open source contributor in the environment on CloudNativePG. I'm a maintainer. And on Kubernetes, on the external snapshot, and all the CSI ecosystem that is it's powering not only Kubernetes, but all the container world.
I'm Gabriele. I've been using Postgres for almost 25 years. I'm also a Postgres contributor, and I'm really proud to be one of them. I want to always remember Simon Riggs, because I owe a lot to Simon Riggs. I was the second quadranter, and I would like him to be here to celebrate what we've done. Okay, so I've been lucky to work with Second Quadrant for many years. Then we were acquired by DB, and now I'm vice president for Kubernetes and chief architect at EDB. I'm also Data on Kubernetes ambassador, so my mission is to promote the usage of databases in Kubernetes. There's also another ambassador here who's Jonathan Battiaso, and I'm also DevOps evangelist, so I believe in DevOps. DevOps are the reason why I embraced so many technologies like Vagrant, Docker, and so on, and Kubernetes, and probably will be the reason, as I always say, that I will move away from Kubernetes one day. I'm also known as the creator of Barman, and now I'm fully active on CloudNativePG. So let's start with the first introduction to Kubernetes from a Postgres database administrator point of view. So Kubernetes is essentially a distributed operating system. It's, in my opinion, one of the most exciting technologies that have come in the last 20 years, okay, or 30 years if we include also Linux and Postgres. Okay, these are my 3 main technologies. It is important to say that when we talk about Kubernetes, we need to think about a solution that manages infrastructure and applications that are containerized. So when we compare Kubernetes with VMs, we are doing something wrong, okay? It's much more. So long story short, Kubernetes is owned by the CNCF, the Cloud Native Computing Foundation, which is part of the Linux Foundation. And it's the first project that became graduated, but there are several projects with, in the CNCF landscape, which is something that you should become familiar with. And there are also tools here that also operate outside Kubernetes, like probably Prometheus. I'm sure you have heard of that. So quick recap, main differences between Kubernetes and VMs. I already mentioned. With VMs, we talk about operating systems. With Kubernetes, we talk about infrastructure and applications, so it's much more. In Kubernetes, containers share the same kernel, whereas in VMs, they each own their own operating systems. We talk about immutable containers in Kubernetes, so you cannot change anything, any binary. We are used to thinking in a mutable way with VMs. We log in, we type DNF update or IPT update and so on. Kubernetes is out-of-the-box portable. I will show you at the end, I wrote an article about cloud neutrality, so we can talk about that. And with VMs, you probably know with change management solutions like Ansible or Terraform, you can achieve portability, but only indirectly. And finally, the most important one is that Kubernetes covers the two operations. So for the infrastructure and for applications. So it means that if something happens, self-healing procedures kick in. And this is a reminder for everyone that works with databases. You can run Kubernetes on bare metal. And as a result, skip any VMs, dedicate nodes to Postgres, and run directly on bare metal with local disk. Okay, so this is very important. So as a DBA, do I need to become an expert in Kubernetes? No, the answer is no, it's impossible. Okay, Kubernetes has been designed to be modular, to basically solve the problem of complexity in IT. You modularize your systems. So what we need to do as DBAs, we have what is called I-shaped profile. We are specialized in databases. We need to grow with more general knowledge about Kubernetes, so that, and eventually even get a pie-shaped or comb-shaped profile. But ultimately, this is the goal. As DBAs, we need to have smart conversations with people that work in infrastructure and understand each other. Okay, break the silos. So the concepts that we believe we should know about Kubernetes are regions, data centers known as availability zones, because Kubernetes could be stretched across 3 or plus availability zones to achieve region high availability out of the box. Nodes. So nodes are the machines where Kubernetes is running. They can be on bare metal, and normally you just install Kubernetes. Then the service resource is what allows you to control how, for example, a Postgres database connects to the application, with the application, or to the external world with a load balancer service. Then understand the difference, like in VMs and bare metal, between network and local storage. And in Kubernetes, there's a standard called the container storage interface, and we've got Leonardo, who's actually contributed to Kubernetes 132 last month, introducing volume group snapshots. Okay, Kubernetes supports now volume group snapshots, and storage vendors will implement what Leonardo and the team have done. And of course, with Postgres, we will benefit from that immediately. So you need to understand the storage class concept. And when you manage applications, Kubernetes has this resource called deployments. So deployments are good for most of applications, but not for databases. Okay, so the idea is that for database workloads, the resources that Kubernetes provides are not enough because they don't understand how Postgres works. The primary standby architecture, backup, and so on. So you need what is called an operator.
So this is a really quick introduction on Kubernetes. So people that are already familiar with it, we need to have a bit of patience. But I may offer a different look than the other tutorials, so I hope still this is interesting. But first of all, let's start with the dichotomy of series of steps to be followed from the start to the end. And okay, this can be debatable because every step could be idempotent, especially if you are used to Ansible. But still, you are following them as a list. On the declarative word, you declare what you need, and you leave the task to devise the current step to execute to an operator. This operator is going to execute. Hearing myself. This is why I asked.
Yeah, because, yeah.
That's the point. Can you hear me? Good. I can hear myself too. So, sorry. Well. Okay. So, good. Set of steps versus declarative. Declarative means, okay, I probe the status of the system. In this moment, I choose the correct step to bring me forward. But I do not choose totally my way from the start to the end. I just choose the first step to be executed, and then I will reprobe the system after a while to compute the second step, if there is one. And this is going to happen continuously, at any time. It's not just the beginning. So the system will try to reach a certain point that the user declared at any time. It's not just following the steps you provided it. But first of all, we need to understand how Kubernetes think about the word. It doesn't work still? Yeah, it's not. Good. Okay, so the word Kubernetes perceives the world in a totally different way. It's really weird. But the world is composed of resources. Every resource has a name, has a namespace, and has a type. These are the coordinates of the resources. You need all of them, actually. And this means it may be surprising because you may have different resources with the same namespace and different type, or different. So we need to pay attention. But the most important bit is every resource has a specification, has a status. This is what operators try to align continuously, the specification and the status. When you interact with Kubernetes, instead of using the operating system that is underlying the nodes, you use a so-called API server. It's nothing fancy. The interface is more or less REST-based. And you have many methods. These are 3. So get the resource information. Every resource has an URL, nothing fancy. You can put a new specification to the resource. And you can watch, so you can request for you to be notified every time the status of the resource change. This is how controller works. It's nothing fancy. So let's develop hypothetically an operator for Postgres. And as users, we require to have one cluster with 3 instances, 3 magic blue blocks. Without any controller, without any operator, we could provide a spec, but nothing changed in the status, because there is no one taking care of synchronizing. But wait, we said Kubernetes didn't have a data type for clustering. That's true. But you can also improve Kubernetes itself by proposing new, they are called custom resource definition. It's just a fancy name for a new type that you can propose to the system. And a new type plus a controller for this new type, reconciling the specification and the status. This is what is called an operator. That's it, no more. People that are used to monitoring or to electromedical devices, they already know what's happening under the hood. It's nothing new. It's just new names for a phenomena we all know. Once you have a controller, what happens? The controller notices that there is nothing on the right side. Look, okay, we need to create a new one. This is just hypothetical. Let's create a new instance. Oh, there's only him. Let's put a read-write flag on it. That's the only thing I have. I'll write there. Then I will get rescheduled. And they tell me, look, Leonardo, something changed. Let me see. Okay, they requested 3. I need to create a new one. That's good. And then another one. And then our hypothetical controller is happy. And after a while, something is going to happen. The node where the primary instance was crashed. The system reacts. Look, that is not the primary anymore. I'm triggered my hypothetical operator. And what happens now? Oh, look, I missed the primary. I need to do something with it. Let's promote another one. And now I am good. But wait, no, I need to compare the specification and the status. So they requested 3, I need to create a new one. Do I really need to do that? Or should I wait for the third one to reappear? This is the point of different operators reacting a different way, and this is another reason why I encourage you to try them all and to see which one you like best. There are many Postgres operators. It's not just, we are talking about CloudNativePG because it's the one we know best. We are maintainers of it. We believe CloudNativePG to be a really good one. But if we look at the history, we start from Crunchy. But there is something to be noticed. First of all, the third column, technology. So you see many of them are based on an existing failover manager, such as Patroni or Stolon. And many of them use stateful set, which is a resource of Kubernetes that is just ensuring for a set of workloads to be there together with the required storage. So they are building on the primitives that Kubernetes is using. And Kubernetes is designed to be symmetrical. So every pod is equal. We as Postgres, we are a bit different because there is one which is a special guy, we need to take care of him, is the primary. Is this a really good approach? It may be because you are using something that's already there, it may be not. We believe it's better to build something custom. We have a custom pod controller. And this is why we are the only one which is directly controlling PVCs and pods. Because our operator is able to do fancy things, so is able to understand when replicas need to be rolled out before the primary because you change a GAC, or vice versa, depending on if you raised your max connections or you lower them, so it depends in which order you need to restart things. The other operators are able to say, they can do the same, but it's more about being hacky and about how stateful set works. Because if you look for stateful set, they just go from the first one to the end. Everything is symmetrical. You need to mix and match. Then about failover managers, we use our own. It's built for Kubernetes and only works with Kubernetes. Meanwhile, other failover managers have been improved to work on Kubernetes too. So again, this is another key difference. We are vertical. Other failover managers do handle many platforms. They are more like the minimum common denominator of all the possible, and we are vertical on it. So that, again, it depends. What it doesn't depend is the intellectual property and the copyright, which CloudNativePG is copyright from CNCF, have been accepted yesterday. And our governance is vendor neutral. EDB created it from scratch, but the intellectual property is of the company. It can be yours if you propose a PR. It's fine. Okay.
Yeah, there's this misconception. This is the EDB operator. No. It's false. Okay, EDB did what I say, something, I mean, extraordinary by releasing the IP and donating that to the CNCF so that this becomes truly an open source, an openly governed operator. So, and it's truly, vendor neutral. So we encourage companies to join. So I'll move on with CloudNativePG. So CloudNativePG is production ready, is used by IBM Cloud Pak, Google Cloud, Azure, Akamai, Tembo. And as Leonardo said, it just joined the CNCF sandbox. So I encourage you to look at what that means, but it's a major achievement. It means that the CNCF, this is now a CNCF project, okay? Then it can be installed in many ways. There's 3.7 thousand commits, 5.1 thousand stars, 69 million downloads on GitHub. This means that it's using continuous integration pipelines. This is, I use these because, I mean, it's an important metric. If you build an open source software from scratch, you got your idols, you know, out there that are many stars ahead. And basically, this is just a sign of appreciation from the world, because we're not doing any campaign saying, I give you $25 or $50 on Amazon if you put a star. Okay, so this is all because people like it and appreciate it and put a star, okay? And this is, so that's about Postgres operators, but this is just to put it into perspective with other Postgres tools. So this is something extraordinary that CloudNativePG is doing if you compare it with, let's say, Patroni, but also all the other tools. Like, I mean, I created Barman. I was happy with 2,000 stars, but, you know, this is, you know, really surprising us. There are 4 pillars why we believe CloudNativePG is a Kubernetes native database. First, as Leonardo described, it's seamlessly integrated with Kubernetes. It doesn't work outside, and it fully uses all the capabilities, and we even improve Kubernetes. We're part of tax storage, okay? So we're very proud to be pushing Kubernetes where nobody has brought Kubernetes before, okay? Then it's all declarative. It's designed with observability from ground up. We support Prometheus out of the box. We log in standard output, and we'll see that in the demo, in JSON log directly, so that you can use Thanos or any other solutions for logging out of the box. And it's secure by default. So we shift security to the left, okay, in everything we do, from code scanning to image scanning to also the cluster, how Postgres runs. We have MTLS out of the box for streaming replication. We disable Postgres super user out of the box. We disable alter system, which is a small patch I did for 17. And this is a recap of the main features. You see the first ones are all about business continuity, high availability, disaster recovery, then also rolling updates, you know, the way Leonardo described how we do minor upgrades of Postgres. I know you'll be asking about major upgrades, but I'm not going to cover that now. Synchronous replication. Anyway, there's so many. And but what we want to talk about today is the microservice database, what we believe is going to be the new way of building applications with Postgres in mind. So CloudNativePG manages global objects of Postgres, so roles, databases, and table spaces as volumes. We recommend to use one application owning one database which owns a Postgres cluster. So we isolate a database for backups, observability, security, access, and so on. This is what we call microservice database. So by default, as I was mentioning, we disable super user access, alter system. We create a user called app. You can change the name, but it doesn't matter, to be honest, because the cluster will identify your database. And we create a database called app owned by app, and that's all you should have. If you need super user access, you go through configuration, which is like this. We follow convention over configuration. So by default, we take default values for you, but you can pretty much customize anything. This example creates the Clapton Postgres cluster with 3 instances, placing that on the Postgres nodes with quorum synchronous replication of 1 instance, and with 2 volumes, one for PGDAS and one for walls. What happens is that we create the PVCs, the primary is created, the read-write service is immediately set so that you can access the primary. We create the first replica, the second, and this is how the read-only service is created. So you can, out of the box, without PG Bouncer, HA proxy, it's all done by Kubernetes with labels. And when the primary goes down, this is immediately detected by Kubernetes. The operator redirects the primary. If the older primary comes back, it becomes a standby. So now, live demo. Yeah, let's cheer up with Leonardo for the demo in it.
Oh, let's pray the demo gods.
So we have a kind cluster. Kind is Kubernetes in Docker. So it means that we have a Docker container that inside basically runs a Kubernetes cluster, where inside we can run multiple nodes and so on. Okay.
Okay. So we start from here. I hope it's big enough. Is it? Okay. So we start from here. This is the fancy way. That means, okay, give me the list of resources whose type is cluster on the default namespace. And the answer is, look, there's nothing. What do you want from me? There's nothing. So we need to propose something to this system. This is the definition I will propose. This is what I was talking before. That's only the specification. I request 3 instances with 1 gig of storage each. And this image name, which is, okay, that will be defaulted, but I need it here, otherwise I need to download the image from the internet, and my computer is a bit clunky with the Wi-Fi. I don't know why, but still, okay. So this is the command to apply the resource to the system. It's more or like a put HTTP method, nothing fancy. Now the cluster is there, nothing fancy, but let's have a look.
So K is an alias for kubectl, which is the CLI of Kubernetes. Okay.
This is better. So we have our defaulting webhook in place, meaning that we use convention over configuration. We proposed a really small definition of the cluster. What we get is that definition improved with all the defaults that are reasonable for this system. Like, as Gabriele was saying, the name of the database. You can change it if you like. You can specify it. We disable superuser access. We do some fancy things for monitoring. I won't explain them all. It's boring and it would take a lot of time, but it's all documented. These are nothing more than the defaults of Postgres. We didn't specify any configuration, so we just got the default.
Yeah, we said TLS 1.3 by default.
Yeah. No, otherwise, yeah, no security by default.
So if you have clients with older version, you need to enable them. Okay.
The most important bit is the status. This is the controller running. As you can see here, the controller, okay, had now 2 instances because it was working, but I requested 3. So this is a snapshot of the system, okay? It's still working. We had continuous archiving, okay? Let's check now. Look, it's there. So I created a cluster with 3 instances. Pods are nothing more than a fancy name for containers. The most important bit is not the container itself, is the data. Data is hosted in the PVCs. PVCs means persistent volume claim. It's more or less something like the ticket that you get when you go to the grocery store and you need to be served to the desk. But in the ticket, you also specify what you need. So you don't have to ask, okay? They only serve you. Look, the storage class is standard. It's the default of this system. It's just a VM inside my laptop, so this is just a folder on the only node I have. But this depends on your cluster and on the storage system you choose. All the storage systems respect a protocol that what is called CSI, Container Storage Interface. This protocol is not only for Kubernetes, but for everything managing containers, such as Docker. And this is what I have been served by the system. I've been served 1 gig of storage for this instance. But you also will get something more fancy.
So storage classes, while you prepare, storage classes allow us to dynamically provision storage. And we can use different storage classes for table spaces, for your PG or the walls. So if you want, you can have walls with one storage class, PG data with another, a table space with another.
So every container has an IP. This is a new. What is new, in my opinion, it's so elegant that you can have services. Services are more or less like virtual IPs. It's not true, sorry for that, but they can be presented like that. They have an IP. Look, it is a different class than this one, so it may suggest something like a virtual IP. Reality is, depending on the implementation of the system, again, it usually is just a set of IP tables rule. And these services, they have an entry point, meaning that every connection you establish against one service will be routed to the entry points, which are these ones. In this case, 18 is the RW, means read and write, so nothing fancy again, it's just the IP of the first one. Why the first one is special? It is always the first one being special or not. The answer is not, but this is special because it is the primary. In this moment, this can change, okay? Other interesting stuff.
Yeah, why don't you show the logs?
So, logs. When you work with container, you usually, applications usually expose logs in a JSON stream. Just like this. This is pretty much unreadable. It's for us humans. This is better, but not so good, but better. And here you have this fancy logger field. This is telling if it is Postgres spamming you or if it is as operator or something else. Okay? So you can isolate stuff.
And there are no logs in the containers.
No.
Okay, so for security, we don't store them inside the containers.
Since this is unfortunately unreadable, we developed. We have kubectl plugin. It's called CMPG. It's more or less like Git. You can develop plugins. This pretty
it's
plugin.
The plugin. Yeah, it's the CLI of CloudNativePG.
Can show you. This is more readable. You can also show the logs of all the cluster.
And the plugin will order them based on the timestamp. Yeah. So we actually have a clear view of what's happening in the entire cluster.
This is more interesting.
With the
Look,
logs.
The first one is booting. Oh no, sorry, it starts from here. And then the second one joins. And then you have the first one starting a checkpoint. And then you have the third one starting. Everything is mixed. This is really nice. It's beautiful to understand how things work together. In my opinion, it's really nice.
Can you show what's inside the DB, Leonardo?
Yeah.
I mean, because I think we have
not so much time.
Start wrapping up.
Whoop.
Do you have any special request? Failover?
Yeah, let's do a failover. This is fancy.
I have a request, more a question, but here is not possible, I guess. What happens if the primary loses connectivity with the storage? When you have network attached storage, who handles if the primary should fail over? What happens there?
So it's basically the storage is reporting that something is not working correctly. Postgres has a readiness probe and a liveness probe, meaning that the system is periodically pinging the containers to check if everything is fine. Since there is no more storage to be accessed, Postgres will not able to reply to our queries. It becomes not ready. And then the controller is notified and will promote a replica, the most advanced one.
Okay, so these are the users. Yeah, you see that Postgres has no password.
No.
Okay, so you cannot access via the network. And then there's the streaming replica user and the app user, which is the application user. And then try and alter the system. Yes, set shared buffers.
No.
Okay.
No.
So there's no way. The only changes are allowed through GitOps. Yeah, I think we should have. Let's just. Connect to the. Are you connected to the Prime? Maybe create a table.
Yeah.
And see the.
Okay, that's interesting. We configure streaming replication using TLS certificates, so you have everything set up. We renew everything. That's a bit painful if you do it. If you do it on your own, but yes, everything is done. Poo, poo, poo.
So Leonardo is creating in the app. Actually, this is the Postgres database.
Yeah. Oh, sorry.
That's okay. We forgive you.
Oops.
You should never use the Postgres database.
I know. Sorry. Oh, there?
And now it's connecting to the replica, and you see that the data is there.
It's
Then
really replicated. We are not
let's
faking it up.
Failover, Leonardo, okay.
Huh?
Let's try the failover.
Yeah. So -w, this means get a watch over the resources and tell me whenever something changes, okay? So it's, actually, let me do that. This is better in my opinion. Then we get the endpoints because we'd like to see everything changing, and then I'm crazy enough to do something like this. Poof, no more primaries there. Another one is elected, look, oops, 21. Huh? Now 21 is the new primary, which is, I don't know which pod is 21, but I will know it.
Okay.
The second one, in this case, it'd be just the most advanced, okay? We don't know. You know what we could do? We could just delete the storage.
Are you sure?
No.
You're confident enough?
No. Never. I'm never confident. I don't care.
And
if it's broken, we fix it. Look, no more storage of the primary, which is the second one. Let's delete the pod 2, the second one. I don't want these smileys. Oops. Okay, look, this is fancy. Number 4 is coming up. And this join is just PG-based backup in this case. So it's recloning because I deleted the storage. What can we do? I requested 3 instances. You need to do something to bring me back another instance. It's not reusing the name in this case.
Yeah. So an applause for Leonardo, please, because he deserves all of that, you know. So let's move to the rest of the presentation. I'll try and be quick. Of course, if you have questions, we can talk later. So I just want to describe them. I mean, so far, what we've seen with Kubernetes, I mean, I'm not going to run database inside, okay? So even major Kubernetes companies would advise you probably even today not to run the database inside and use a public service, okay? So this is what we call the DBaaS approach. But this is what is happening now. This is the most, let's say, spread use case for CloudNativePG. We've got organizations with clear, you know, for Conway's law, separation between the developers, infrastructure, and database people, that they create their own Kubernetes cluster. Each one has their own Kubernetes cluster for security, which is horrendous, in my opinion, okay? But maybe they have the database in another namespace, but still they treat them differently, and they provide what we call internal DBaaS, okay? But where we want to go is what I was saying, the microservice approach, where application developers, application teams own the database, and they make it part of their pipelines, okay? So the database sits next to the application, and you update them the way you want. So if you want to know more, this is a blog article I wrote a long time ago about microservice databases. And if you want to try even more, this is what we've done in Kind. We simulate a 2-region infrastructure with 3 nodes for Postgres. If you follow that URL, this is all open source. You can try on your laptop to migrate from one region to another, the primary. And we use min.io for object store backups. So I want to finish with this graph. I mean, this is, we know, people that have been with Postgres for a long time, at the start it was just bare metal. VMs came out, and everyone was laughing. I'm never going to put a database in VMs, okay? And this is what we believe is happening now. Okay, with the sandbox, we're basically early adoption. We are now applying for the incubation as CloudNativePG, which has the symbolic meaning of crossing the chasm and becoming an adopted solution. What we think is going to happen now, and that's the opportunity for everyone, is to enter the cloud-neutral era for Postgres, okay, which embraces also Day 2. Day 2 was only possible with DBaaS solutions. Right now, we believe that with CloudNativePG, you can actually create cloud-neutral databases with Postgres, use the same technology, and put your data wherever you want, on-prem, public, multi-cloud, hybrid. That's really up to you. And in Europe, this is important for data sovereignty reasons. The Data Act that also encourages data portability. This is very important. If you want to know more, this is a blog article I wrote for the CNCF blog. And my friend Sean Thomas, who wrote a book about high availability on Postgres as well. He recently published this article. He wrote about how Kubernetes killed the high availability star and how he believes the future of HA in Postgres is with Kubernetes. So to conclude, Postgres is again the most popular database. And now with Kubernetes, you have the possibility to break free from any vendor lock-in with the CloudNativePG stack. And you can achieve cloud neutrality. Our suggestion is to start with the DBaaS approach, but if you can, as a DBA, involve the development team, be part of a DevOps multidisciplinary team with infrastructure people that will understand this. Infrastructure people will really understand this solution. They can spin it up in 10 minutes. A DBA with no Kubernetes knowledge will take a month, probably, to set it up. But they don't know Postgres. That's where you need to come in and take care of the cluster resource. So I was told that there's going to be a workshop in Zurich by EDB. If you want, you can participate, and that's it. I don't know if we have time for questions, Maurizio.
I think we should have now a short break for a coffee, but perhaps maybe 1 or 2 questions now, and then the remaining over the coffee.
Okay. One short question. You spoke about replication, but in your slide was about continuous backup. So is there also another mechanism that does backups, or it's so? It is not.
What would you like? What would you like for backups?
Say some dumps at nightly dumps or.
So PG dump, you mean? So the logical snapshots. Okay, I mean that's not continuous backups. Okay, logical dumps. I mean you can do them. You just need a client connection. So for example, we know we're actually trying to push users to find other tools to do it. I know that there's a tool called PG Back Web or something.
PG Back Web, yeah.
Like that all they do is taking dumps of Postgres databases, and rather than reinventing that, we suggest to do it. But literally, it's just running a job with a stateful set that connects and dumps the database. If we want to do PG dump, what we are actually doing with CloudNativePG, we have created CMPGI, which I didn't mention. It's actually an framework for extending CloudNativePG, and we have started from the backup. So we have made CloudNativePG pluggable, so that, for example, WallG developers can create the WallG plugin for CloudNativePG without even touching the operator. Okay, this can happen now, and we already have Barman Cloud outside the operator. We will keep it for a few releases, but there's already an external plugin that you can use to perform continuous backup and point-in-time recovery. Okay.
Thank you.
No worries. Thanks for the question. We killed you, so we killed you.
Maybe just a few words about the snapshots. How you do the snapshots? Which kind of snapshots, and just a couple of words about that.
Oh, I think I already have my mind.
Right, yes.
So, okay,
I get excited.
About backups, CloudNativePG is, let's say, it has already a backup implementation using snapshots. Snapshots are a primitive resource of Kubernetes that lets you require a snapshot, okay? We are coordinating snapshot. So that means executing PG start backup, taking our snapshot, and then that's it. And then we hand the backup. We save into the Kubernetes snapshots all the backup label, the wall where it started, the LSN where it started and ended, and everything needed for you to restore the snapshot. We are developing actually another backup method which is called group snapshots. That is something new from the latest release of Kubernetes where my contribution is. That means you will be able to take a consistent snapshots, right order consistent across multiple volumes. If the storage class allows you to do that, and many storage classes they're able to implement this stuff. So yeah, we have Barman Cloud inside the operator, snapshots, and volume group snapshots. Barman Cloud is going to be migrated into a plugin. Internet releases.
This is a talk I gave in Chicago 2023, and we restored 4.5 terabytes in 2 minutes with volume snapshots. Okay. So, and we are delegating everything to the storage. And for example, the major storage, they already implement these, and we get it out of the box because it's a standard resource. And where I think we did an amazing job is in the volume snapshot objects. If you take a volume snapshot and look at the labels and annotations, you understand what you have already. Okay, so anyway.
The main point here is that we always try to address problems in the correct software when they should be addressed. If we are dealing with something that is not working correctly or to be improved in Kubernetes, we improve it. This is what we did with group snapshots.
Yeah, we push it down.
We began working with them. Okay? We are pushing. And when we feel we need something in Postgres, we contribute it. When we feel the operator is missing something, we work in the operator. So this is why maybe if you compare feature-wise different software, you will get different feature set because everyone has a different, let's say, contribution strategy. But what you get here is a really stable solution because everything is addressed in the correct software layer. It may become a bit late, but once it's there to remain, not to be removed because it's just some quick fix.
And also quickly, I mean, just to point there, we're trying to change the way extensions run in Kubernetes so that you can bring your own extension on the fly, like, for example, timescale, PostGIS, any extension, okay, PG Vector, and be immutable. So there's a patch with Peter Eisentraut. We are working on that. And also, Tobias, I know you're involved in that, so thanks. Okay.
Okay, then, yeah.
I have a last question, if you don't mind. There was a talk earlier today about challenges with upgrades. major upgrades. So how does CloudNativePG can handle them?
So, okay, we believe that major upgrades should be done through logical replication. Okay, we believe that you should have a new server. Okay, but we get the request that this in-place upgrade concept is needed. I'm scared about extensions, to be honest. Upgrading extensions on the fly in an immutable environment. So, I mean, we say we don't do it. Crunchy, for example, Crunchy operator does them, but for example, as far as I know, maybe Karen can confirm, PostGIS is not supported. Okay, upgrades of PG upgrades. This is a complex solution. Okay, so we believe that already you can migrate, like you should before, from IDS to CloudNativePG with zero cutover time. Or you can perform upgrades with we have declarative subscriptions and publications. You can already create publications in your source and subscription in an origin. And with the plugin, we have a command that updates sequences. So we're working with the PG upgrade stuff. The problem with PG upgrade is that you need a rollback strategy. But if you roll back, the observed status cannot match the required one. And so we will need manual intervention at that point. Because you requested to jump to 17. We tried, it failed. We rolled back, but the status says, I want 17, but I still give you 16. So we are working on that. So the plan is to have maybe in 120, not the next one, hopefully the other one, some basic PG upgrade support for those who want, because they manage hundreds or thousands of clusters in the same Kubernetes cluster. Because these are the numbers we see. Okay, so this is not a joke.
No.
And we need DBAs. We need Postgres DBAs in this world. So again, it's an opportunity, in my opinion, for all of you.
This is powering a few DBAS services.
Yeah.
So I mean, it's
okay.
Okay, thank you very much. Another round of applause, and we can ask questions over the coffee. Thank you.